In this lecture, we are going to explore laws of motion. This is the name of a lecture. Name of this lecture is laws of motion. From this given name, you can guess, you can understand, you can observe what it is trying to tell you that we are going to understand the properties of motion. Something will happen, it will happen because of there is a reason. Okay, so laws of motion we are going to explore. Here you will observe what motion of an object, different type of motion you will observe. Clear? So from this slide you understood, you saw that name of this lecture is going to be laws of motion, and my name is here. You can see I am moving towards this slide. We are starting from force. This is an introduction of a force. Let me explain from my language. Look, whatever you push, whatever you pull, okay, whatever you lift, whatever you push downward. So all these are what? All this is force. We say we apply force with the sum Newton. When we will apply force on object, then of course object will move. So are you observing? Here I said what, if we apply force on object, then of course object will move. Okay. In other case, if we apply force and object is not moving, it means we are not applying what? More force. Force is zero. If object is not moving, then we can say force is zero. Okay, force will move when force will be greater than zero. Clear? So also remember, if we apply any kind of a force, on the object, then object will move. Okay, object will move, object will cover distance. You can. So force is just a push or pull, a lift, a downward force, upward force. All these are force. An object. Okay, clear. It can change. What what uh, what does force change? What can force change? So here you can see the state of motion and object. For example, an object which is in motion, an object which is in rest will come into motion, and it will happen when force will be applied on object. Well, let's assume that in front of you is an object, and that object is in state. Now you are going to apply force on that object. So what will happen? You will observe that that object came into motion, and it happened because of you applied force. That's why. Now next is the shape of an object. Yes, by applying force, uh, shape of an object can be changed. How? Let's assume you have a balloon. Uh, Otherwise, you can have what? You can have a paper. You can have a book. There are a lot of objects that can be taken as example to understand that the shape of an object can be changed. I am taking what? A book. Now when you will rotate your book, then here you applied, that's why you are able to roll your object, your book. And here you can see now shape of your book became something else. Okay, something else. So it happened because of you applied force to roll your book. Clear? In this figure you can see this woman is pushing this cart. this person is pulling this arrow, and this person has what magnet, and here apple is falling is known as a gravitational force, and here you can see this boy is riding a cycle which is coming from upward to downward. It is also a friction force, and here acceleration. This is known as acceleration. When acceleration, which means we are in a speed, then we apply force in moving. If we are applying force more after some times, it means you are uh, you are applying acceleration. Okay. So in details, I will explain about acceleration. For now, let's understand what is this figure trying to tell us. This figure is saying that all these are force. All these are force. Push is also force. Pull is also force. Magnetism is also force. Gravity is also force. Friction is also force. Acceleration is also force. Now, always remember, by applying force, a moving object can be accelerated. Okay, can be accelerated, can be deaccelerated. Clear? Clear? Okay. Here, if something is falling from upward without any contact force, then that force will be known as a gravitational force. Always remember. Now friction is just a opposite force. It works to stop a object. It blocks the object. Okay, it is just a opposite force. Push or pull. It is a defined. This is a definition of a force. Magnetism. So it is a type of a force. This is also type of a force. In details we will be understanding in our next standard about the magnetism force, about gravitational force, okay, about friction force, next section. So I am moving forward. Now types of force. As you can see, types of force. First is a balanced force, and next is what? Next, where are you? Hold on. Next is types of a force. Here, as you can see, we have two types of a force. First is balanced force, and second is non-balanced force. First is a balanced force, and second is unbalanced force. There is a twist between them, but balanced force, here you can see, as we understand a equation in mathematics, same here you can understand balanced force. It will say that force are in both side, in left side as well as in right side, and force with the quantity in both sides are same. For example, in one side force is how much? Let's just say 20 Newton. So in other side, in right side, force is the same. Amount of a force is the same, which is 20 Newton. So in both sides are same. That's why we will call it as a balanced force, because of both sides has the same force. That's why. And here, if both sides either uh, okay, I will tell you about it. Here, if both sides forces are same, force quantity of force or in both sides are same, then always remember, uh, object will not move. Object will not move. Object will be as it. If object is in motion, and forces are being applied in both sides, then always remember that object will be moving with the same with the inertial speed. Okay, with the inertial speed, it will happen when there will be balanced force in both sides. Then now let's see unbalanced force. Change the state of motion. Yes, here you will observe what if there is an unbalanced force in a figure, then you can easily say that yes, a object is moving, a object will move, you can say. Now in details, let's try to understand unbalanced force. So it means if in a side forces are how much, 50 newtons. Okay, now in other side forces are 20 newton. Now now you can see both sides forces are not equal. That's why we will call it as a unbalanced force. Now what will happen if we have unbalanced force? What will happen? So here first of all motion will change. Uh, object will come into motion. This will happen. Okay, this will happen. Now what else motion object will come into motion. Okay, by applying more force in one side and in another side force is less, then we can easily say that we are accelerating. Okay, we are increasing a speed. Okay, okay, with imagination I would like to tell you about it. Let's assume that in one side forces are how much, 10 newton, and in another side forces are 20 newton. So object is in between. So in which side object will move? So of course forces where are less, where forces where are less in that side that object will move. Okay, clear? So it will happen uh, when a object is being pushed then. Okay, but in the case of pulling, it will be opposite. For example, let's say the same, in one side 10 newtons and in another side 20 newton. Now object is being pulled. So now in which side object will move? You would say in which side. So if one side in left side is 20 newtons and in a right side is 10 newtons, so of course object will move in 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 a left side. Yes, because of object is being pulled, that's why. So always remember, if a object is being pulled with unbalanced force, so of course that object will move in side where newtons are more. And in the case of pushing, object will move in that side where amount of newton is less. So in that side object will move in the case of pushing the object. Clear? Now next is contact forces, non-contact force. It is also important, and we saw this, but little we saw. Let's expand the definition of a contact force and non-contact force. Also remember, if we apply contact force, it means there is a object and there another object is with contact of other object. A contact of a object is with another object, then force is being applied with one object, then we would say yes, both are in contact to each other. Okay, same here. non-contact forces, here only a object will move, but contact of another object, only a object will move. So there would not be any contact of another object. It would act without any contact. Non-contact force would act without any contact. Clear? Always remember. So examples of non-contact forces are muscular force, which means our muscles of animals, muscles of living things. And here friction is just a opposite force that blocks the object. Non-contact forces are gravitational force, magnetic force, electrostatic force. In this case, you will observe that there is a nothing, but a object is moving. You can take a magnet and just put some nickel irons in front of a magnet with some distance, okay, with some centimeter. Now what will happen, that magnet will attract iron nickel. This is what will happen. So it is happening because of we have a magnet, that's why. So this kind of a force we will call it as a magnetic force also. Clear? And in the case of a gravitational, we will see that something is coming from upward, but there is nobody who is applying force on that object, but that object is in motion with a speed. So it is happening because of a gravity. It is happening because of a gravitational force. This kind of force we call it as a gravitational force. Now we are moving. Hold on. We have two figures. Let's understand it as well. We have two figures. In this figure, this side there are four peoples, and this side there are four peoples, and each this both group of people are pulling the rope. Now here quantity of this side is the same. Quantity of Newton in this side is the same as compared to this. So this figure is showing that it is a balanced force. It is what? Balanced force. Clear? Because of amount of Newton in this side is something and same in both sides. Amount of a quantity, amount of force, amount of newtons are same. Now in this figure, what is happening? Both this person, this girl, this boy, both are pulling this third person. Both are pulling this third person. Okay, this is third person. Now what will happen? Now here you can see this person, he is pulling with 10 newtons and she is pulling with 6 newton. Now what will happen? We can easily say that it is not a balanced force. We can easily say that it is not balanced force because of in both sides amount of newtons are not same, that's why. Clear? So now what will happen? Object will move in this side or in this side. So easily if case is what? Pushing. Case is a pushing. No, case is a pulling. So in the case of pulling the object, side where the side where amount of newtons are more. Here you can see in this side amount of newtons are more, that's why this object will this person will come into motion in this side. Okay, so it is an example of unbalanced force, and this figure is an example of this figure is an example of unbalanced force, and this figure is an example of a balanced force. And here this is a contact force. Which force? Muscular force. And in this also contact force. And which force? muscular force. Always remember. Next, hold on. Next, we have Newton's law of motion. We are starting with the main topic of this lecture, Newton's law of motion. First law. First law of Newton is also known as a law of inertia, and both we will understand, and definition of both uh, will be same. Little bit will be same. I would say completely would be same. Meaning of both uh, first law of Newton and law of inertia will be same. So first law says an object remains in its state of rest or uniform motion unless acted upon by an external unbalanced force. It is in book language. Now let's understand from our language. Our language. Now here. Always remember. I always say that always remember. Here there are a lot of objects that you can see, and those a lot of objects are in a rest. Are in a rest. But in the other case, we can also say that there are a lot of objects which are in motion. Which are in motion. So in first case, objects which are in rest will be in rest. We are not going to do anything with those objects which are in rest. Okay, this is what first law of motion. This is what first law of motion. Newton's first law of motion. Okay, object will be in rest if object is in rest. In rest. Now, if object is in motion, is with uniform motion. Okay, if object is in with uniform motion, so that object will be in motion. Will be in motion. We are not going to do anything with that moving object with uniform motion. We are not going to do. And if we apply external force, then something will be changed. Object which was in rest will come into motion. Object which was in uniform motion will come into acceleration motion. Acceleration will come into accelerator. So this was a definition. This was first. This was the Newton's first law of motion. Now next is inertia. Inertia. As I told you that law of inertia is also known as Newton's first law of motion. Let's see inertia. The tendency of an object to resist a change in its of motion. Now what will happen, brother? Same remember, as we saw Newton's first law of motion, same fourth law of inertia you can remember. In the case of law of inertia, we have three: inertia of rest, inertia of direction, inertia of motion. We have three. So inertia of rest, if a object is in rest, will be in rest until we will apply external force. This is the inertia of rest because of object is in rest. Now next, a object is in uniform motion. Inertia of I am talking about inertia of motion. A object which is in motion with uniform speed will be in motion. If we apply force, external force on moving object, so that object can stop. That object can be stopped. Either that object can be stopped or can be or a speed can be increased and decreased. This is what will happen when we will apply external force on moving object. Now, what about direction? Okay, a object we are driving a car. Okay, we are driving a car. Now, the car is going in a straight direction. If a car is going in a straight direction, now we are thinking that yes, now it's a time to take turn into this direction. This will happen when you will apply. A car will be going into a car will be moving in a straight direction, but that car will take a turn into another direction when external force will be applied. Same here, if we are driving a car, any kind of vehicle. Now we are in straight. We are driving a car in straight direction. Now, if you turn into another direction, so of course here you will apply external force, which will be in your car device. Okay? This was the law of direction. Now next examples. A book on a table stays at rest until pushed. A moving car stops when brakes are applied, and brake is the external force. A moving car will come into rest when brakes will be applied, and it will happen due to friction, which is external force. Now next, second law. F is equal to ma. F is equal to ma. So F, which means force, and m is magnitude, and a is acceleration. We are applying force. Okay, so of course we will be applying a force on object. Now if we are applying a force on object, so of course that object will have mass. Now when we will apply force on that object which has a mass, of course that object will accelerate. It means that object after initially speed of that object will be more, but at the final position the speed of that object will be less. Of course it will happen when we will apply a force on object which has a mass, and that object will accelerate. Initially a speed of that object will be more, but at the final position the speed of that object will be less. This is what will happen, and it is happening in today's time. Now it is a nature, we can say it is a nature. The rate of a change of a momentum of an object is directly proportional to the applied unbalanced force, and takes place in the direction of a force. Always remember, if mass of an object is less, then of course we will apply less force. This is what it is telling you. If we have a object which mass is less, so of course we will apply less force. In other case, you have a big object which mass is very more, Now of course you need to apply more force so that that object can move from one place to another place. Okay, this is what should happen, isn't it? And this was meaning of this F is equal to ma. Clear? Till here it is clear. Let's see what is the formula. Formula is F is equal to ma. To calculate a force, you should have m amount of mass of an object and amount of acceleration of an object. When it comes to acceleration, also remember it is equal to v final position minus initial position upon t. So force unit of a force is n, and unit of mass is kg, and unit of acceleration is meter per second square, because it has what it has a speed, and as you know speed is considered in meter, and here second, because it of course if a motion if a object is moving, of course that object will cover time. Now always remember, force will be represented as F and mass will be represented as a small m, and acceleration acceleration will be represented as a small a. Okay, this is what will happen. And now, for now I am moving towards it, because if as of now it is enough to understand. A heavier object requires more force to accelerate. Yes, 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 of course. You have a you have a bike. Okay, now you can assume that yes, mass of a bike is very high. If you want that object should be moved in house so that it can be safe. Now what will you do? Uh, you will take bike and uh, you will push the bike wherever you want to stop. So here I am trying to say that you will apply more force so that bike can move where you want. Okay, kicking a football harder increase its acceleration. Increase. If you kick a football very hard, then of course acceleration of that object will be more. Next, third law of motion. Third law, which is last. Third law, we can remember it as action reaction. If we apply action, then you will get a reaction. For every action there is an equal and opposite reaction. It is a simple thing. Here you can see there is a boy who is applying uh, one leg of his is here and one leg is here. So he 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 applied action here, and reaction would be what? This what will go to this side because of he applied force. That's why. Now here, from Newton's first law, you will get what? You will find, you will see that yes, force is being applied. From Newton's first law, you will understand. Now from second Newton's second law of motion, you will understand that object is moving. Force is being applied on object, but with how much force? This is what we calculate in Newton's second law of motion. We will calculate force, with how much force were applied on object. Okay, this is what we will calculate. We will do a lot of calculation in Newton's second law of motion. From Newton's third law of motion, you understand that what would be nature of acting force on object. What will be nature? Of course, if here you can see nature of this figure is what? It is going backward. This is what is the nature. Now next. A swimmer push water backward to move forward. Yes. If you want to go ahead, then you will have to push backward. Now next, momentum. What is momentum? Always remember, if your mass of your body is how much? 90 kg, and you are running with this much speed. So of course this will be total momentum. In the other side, let's assume mass of your body is 100 kg and velocity is the same. Now what will be momentum? This will be momentum. Now who will be moving faster? Of course, this will be moving faster because of in both cases velocity is the same, but mass is a different. In this case mass is less, and in this case mass is more. That's why this in the first case this a person will move faster. Okay. Now in this case you can see momentum is equal to, we will understand it in someday. Law of conservation of momentum. Total momentum of two objects before and after collision remains the same provided no external force acts. Objective equation. Force is what? Push or pull. Newton's first law is called also the law of inertia, as I told you. SI unit of a force is, always remember it is what? Newton. Momentum is defined as I think momentum, here you can see P is equal to mv. P is a momentum, m is a mass, and b is a velocity. Also remember, velocity takes a time and it has a speed. That's why meter per second. Meter is considered meter. Unit of speed is meter, and SI unit of time is a second, and SI unit of mass is what? Kg. So formula of momentum is a mv. Now next question. Action and reaction force acts on the what? Same body. A force can change shape of an object. Yes, can change the speed of an object. A moving object continues to move unless acted upon by the formula for forces would be what? F is equal to ma. The unit of momentum is what? The I think unit of, so unit, I think this should be unit kg into m per second. Okay, friction is a type of opposite force. Clear? Friction is a type of opposite force. Okay, done. Now next is a defined force. This is for you as homework. Now next, you have 10 questions as subjective. The end. So we have completed this chapter, which name was what? Laws of motion. Laws of motion. That's all. In other lecture we will be explaining something else, which name would be something else. So in this that's it.